this video we are going to take a look at the important components of a scanning tunneling microscope. Here you can see the schematic view of a STM. The tip is often made of tungsten, platinum, iridium or gold. Requirement for a tip material is an extremely high conductivity, of course. The piezoelectric element works similar as for atomic force microscopy. It is able to convert a signal from the control unit into deformation and therefore adjust the height of the tip. The distance between tip and sample is somewhere in the range of 0.5 nanometers. An electric voltage between tip and sample is applied to increase the probability of tunneling. Still, a potential barrier exists due to the distance in between sample and tip that electrons are not supposed to pass. However, a very small tunneling current in the sub-nanoampere range can be measured anyway. The tunneling current is very sensitive to the slightest changes in the distance between tip and sample because the tunneling probability decreases exponentially with increasing sample-tip separation. If there is now a topographical elevation on the surface, this can be registered by an increase in the tunneling current. By scanning the sample, a two-dimensional image can be generated. But that isn't all. We need to keep in mind how sensitive this method is. You can measure single atoms, that is unbelievably small and an extraordinary resolution. That is why you can also take the following as kind of limitations for STM. If you do such measurements, you need an ultra-high vacuum system. As a rule of thumb, you can remember that for a pressure in the range of 10 to the minus 3 Pascal, that is high vacuum, you get one monolayer of crab each second. And as you can imagine, that is not good for scanning tunneling microscopy. Then, your instrument must be isolated against mechanical vibrations and noise. Both would make the atoms in your sample vibrating in an order that you would not be able to measure anything. In addition, these instruments must be electrically isolated. The tunnel current is that small that it could be easily disturbed by external electrical sources. And last but not least, you need a good thermal isolation. Your sample must be cooled down to extremely low temperatures, liquid helium temperatures to be precise. That is 4.15 Kelvin. Otherwise, the oscillation of the atoms would be too large to measure anything. That are the reasons why STM instruments are very big, heavy and expensive, as you can see here on that picture which I got from Wikipedia. But well, that's it for this video. Thanks for watching and see you in the next one.